How are crystals and minerals created? It is common to see the words crystal, mineral, and gemstone being used interchangeably. However, it is vital to understand that they are not necessarily the same things. While they are related and often placed together, crystals, minerals, and gemstones have very different properties that can be observed under the microscope. Crystals. Only a small percentage of the materials that make up our world are crystals. And as such, there are a few ways to pick them out. They are produced by the natural process called crystallization. Still, it isn't always easy to find a crystal with so many other materials being formed through the process. They are usually found in igneous rocks, which are formed through volcanoes and different mineral processing, or they can be found in sedimentary rock. Some examples of crystals include salt, sugar, and snow. Minerals. A mineral is a generic term for a naturally occurring substance formed of one or more elements. It does not include natural objects such as rocks. Minerals can be any number of different materials, but are usually defined by their chemical composition and crystal structure. They are usually found in igneous rock beds and can be distinguished by various physical properties such as hardness, color, and density. Minerals come in many shapes and sizes. However, most have a unique look, which makes them easy to spot. Some examples are gold, silver, iron, and calcium. Gemstones. These are the most colorful and interesting of the three, but are also the hardest to find. Gemstones differ from other minerals in that they are primarily used in jewelry making and decorative design. They must also only be found in certain places and must not contain impurities or defects. It is rare to find a genuinely natural gemstone, as it must either be mined or grown artificially under laboratory conditions. Diamonds, emeralds, rubies, and sapphires are all commonly known gemstones. They are mostly found in igneous rock formations, but can also be mined from metamorphic or sedimentary rocks. Crystallization. Crystallization is a natural process in which crystalline substances form through changes caused by heat, pressure, and time. When liquid water is subjected to very high temperatures, it can turn into a gas and then begin to cool. This cooling process occurs on an element's surface, leading to the tiny crystals or grains forming. These grains can then be melted together and affect other molecules, causing them to grow. This growth process is known as nucleation. It is the process where the molecules of the substance can grow and form grains by removing themselves from liquids or by adding molecules from another substance. These grains then can grow in size, eventually becoming large enough to be detectable to the naked eye. Nucleation occurs when an atom or molecule becomes tightly bound to something else, such as when one molecule attaches itself to another molecule within a liquid or gas. Crystals and gemstones are the results of nucleation. Types of crystallization. There are 3 different types of crystallization. The first type is known as the mushroom or lamellar crystal. This process takes place on the surface of an element. A liquid or vapor can nucleate and grow into a crystal when it touches the surface. This type is used in many processes, such as producing salt and sugar. These crystals tend to be very small, expressed visually through their atomic structure as having needle-like points to their particles. They are also very fragile and prone to shattering, making them difficult to use in many applications where high strength is required. The second type is the spirulite. In this process, atoms or molecules become linked in a chain-like structure. Those closest to each other continue to grow and can eventually arrange themselves in a visually recognizable pattern to scientists. The process is known as a growth and occurs at temperatures of 300 to 500 degrees centigrade. An example of this type of growth would be snow, which crystallizes when water is cooled enough to freeze. This growth process can occur at any temperature, although the rate is much greater at temperatures close to the freezing point. Snow crystals are very common, and their visual expression reveals clusters of grains that seem like light bulbs above a sea of white.